All right, so very good, very good, very good. You are welcome again, and thank you for staying tuned. You are still with us. God bless you. So, as we said it earlier, we are continuing with the rationalization. Our previous video, we looked at how to tackle problems which the denominator being a sample set, that is a monomial, are you with me? And this time around, we are going to tackle problems with which the denominator contains set as well, being what a complex set or a compound set. Are you getting me? So, being it a binomial, how to tackle it. So, I told you in my previous video that for problems involving fractions with set, with which the denominator is a set being a single set, we have a way in going about it. In the same manner, in the case whereby the denominator being a binomial has a way in going about it, and this is what we are going to look at it today. Before I will continue, I will I will say that please do not forget to subscribe to this channel so that you'll be the first person to get in touch with our video anytime that we upload videos on this platform. Okay, and one more thing also is do not forget to share this video or to share this channel to your colleagues who are out there who need help, okay, in this field of mathematics, so that they will also be redeemed from their problem. Don't worry. Thank you for accepting my decision. Now let's continue with life. We are going to go through with question number one and question number two, so that I believe that when you stay tuned with us, the whole thing will be unique. The whole thing will be good, and you will enjoy the lesson today too. Good. So let's start with question number one. Problems involving binomial denominators or compound denominators. Very good. So question number one, let me write down my solution. Okay, so I'm done writing down my solution. Now let's see how to solve this, how to rationalize it. So I told you that rationalization, the essence of rationalization is to get rid of the radical sign that is affecting the denominator. Now the denominator is a compound set. It has a radical sign here. So we are doing the rationalization in order to get rid of this radical sign, to make sure that it goes away. And before it can go away, we cannot just take it and throw it away, or we cannot just erase it. No, it needs to go through some process, and that is the essence of rationalization. Good. So the question is, what is the approach for this? The approach for this is, because the denominator is a binomial, I get you. That is one term and the next one. Now have it in mind that anytime that we can determine whether an expression is a binomial or monomial, we have to be abreast with these operational signs in mathematics. So plus and then minus. Okay, so far as we have one of these signs in between the two and this, that is why we are saying that this is a binomial. This is one term and this is the next term, making it what? Two terms. So having problem like this, what we are going to do is we are going to first of all find the conjugate. Take note of this word. The conjugate. We are going to find what? Conjugate. I want you to also pronounce it conjugate. Conjugate of the third. We only find conjugate when the denominator is a binomial or a compound set. I would mean. Very good. So find the conjugate of the binomial set 2 minus root 2. What we are going to do is we are going to find the opposite of this binomial. So the sign in between the terms, that's what changes. So the conjugate of this becomes 2 plus root 2. So the conjugate of this is this. I get it, me. Very good. So I I told you that conjugate simply means you are changing the sign, the operational sign. So if here is negative, the conjugate becomes what? Positive. If here is positive, the conjugate becomes what? Negative. And that is all. Please, are you with me? Very good. So now let's start with the process. So I said that you first of all check the denominator. If it is a binomial, you find the conjugate. Now we realize that the conjugate for this is that. So I'm going to multiply both the numerator and the denominator by the conjugate of the surd, which is a binomial. So I'll multiply both the numerator, which is 2 plus root of 2 all over 2 plus root of 2. I get any? Very good. So after doing this, then I'll continue with the process. Please do not forget that you always check the denominator. If it is a binomial set or if it is a compound set, you find the conjugate. But if it is a simple set or monomial, you do not find the conjugate, you just multiply straightforward. Are you with me? Very good. So let's see how to multiply that. Now mathematically, I can rewrite this one as 3 in the bracket 2 plus root of 1, 2 all over 2 minus root of 2 multiplying 2 plus root of what? 2. Are you with me? Very good. Let's continue with the process. Now this root 2 here has a whole number 1 in front of it. In the same manner, this has a whole number 1 in front of it. This one too has a whole number 1 in front of it. So please do not get confused. Alright, so let's continue with the process. Very good. So here we are going to expand it. So we have 3 in a bracket 2 plus 3 in a bracket 1 root of 2 all over. So here we have a binomial multiplying a binomial. So this one we take charge of everything here. So I have 2 in a bracket 2 plus 1 root of, then my minus 1 root of 2 multiplying everything here. So 2 plus 1 root of 1, 2. I believe you are following the process. So this is a binomial expansion, binomial multiplying binomial. So that's the take charge of everything. That's what we are having. And the second thing, which is negative root 2, will take charge of everything. And that's what we are having here. So this, I believe it is good. Good. So let's continue with life. We continue with life. Very good. So now we can multiply that. So here we multiply 3 by 2 and we are getting what? 6. Then here we multiply 3 by the positive whole number, not the 2 here. The whole number. I'll keep on saying that we multiply this whole number by the whole number there. So we are getting what? Positive 3 root of 2 all over. Here too, let's continue with the expansion. I'll multiply the whole number by the whole number 2 there. Okay? The whole number and the whole number by the 2 there. But before that, let me make it easier so that you understand it more. Should I expand it straightforward or I should take my time and do that? Okay, so let's take our time and do that. So I have 2 in the bracket 2 plus 2. So 2 is taking charge of that after it will take the charge of everything here. So I have 1 root of 2. I good. So after this we take charge of this, then after it will take charge of what we have over the 2. So I have negative 1 root of 2 in the bracket. So when we do it in this manner, 2 plus 1 root of 2, then bracket close. Okay. So let me solve here and after I'll expand this one also. So I have 6 plus 3 root of 2 all over. Expanding this here, I'm going to get what? 4. Here I'm going to get what? plus 2 root of 2. And I'll come here. So negative 1 root of 2 in a bracket. 2 plus 1 root of what? 2. After I'll expand this one also. I believe you are with me. Very good. So let's continue with the process. So I have 6 plus 3 root of 2 all over 4 plus 2 root of 2. So that one you can take charge of this one after the other. In a bracket 2 minus 1 root of 2 in a bracket root of what? 2. So here being 1. Are you with me? Yes. We should have done this over here straightforward, but because I don't have space here, that is why I took my time multiplying this to get this, and after I expanded it one after the other. You can choose to multiply it straightforward, but I want you to understand what I will get at the end of the day. That is why I've taken my time saying that this will take charge of this will take charge of that. That's why I've done it like that. But if you get the understanding, you can easily multiply this one straightforward. I believe it is clear. Very good. So let's continue with line. Now I'm having 6 plus 3 root of 2 all over my 4 plus 2 root of 2. Then I'll come here. The whole number 2 will multiply the negative 1. Or I'm going to get what? So this is what I'm going to get. Remember, this is a whole number, and it is going to multiply this whole number 1 here. It will multiply. Well, that's what I'm getting what? Negative 2. That. So here too, the whole number will multiply that. I'm going to get what? Negative. I'm going to get what? Negative 1 root of 2 times 2. Okay, are you following? I believe you are following. Very good. So here, let me clean over here and I'll continue from there. I believe you are following the process, and I believe you are not in a state of dilemma. You are on the process and you are following. Very good. Don't worry, if you have any question, you can ask that in the comment section. We will get to you and answer your question for you. Don't worry, but follow and make sure you get it. It is not difficult. We are trying to make it easy for you so that you will understand it more. Good. So let's continue with life. So from here, we are getting 6 plus 3 root of 2 all over. So I'll come here. 4 plus 2 root of 2. I'll come here. Negative 2 root of 2. Then I'll come here. Negative 1 root of. I'll multiply 2 times 2, which is giving me what? 4. Are we good? Very good. So let's continue with life. Now I have 6 plus 3 root of 2 all over. So here, let's group like terms. Now have it in mind that root 4 will give you something. Okay? So continuing with life. I'm now having 4 plus 2 root 2. Now I have negative 2 root 2. Now I have negative 1 root of 4. Now you can see that this positive 2 root 2, negative 2 root 2, they are like terms. So therefore, you will cancel each other. I get it, they are like terms. That is like you're having 2 minus 2. It is similarly, it is like you are having 2x minus 2x. This one gives you what? 0x. And we don't write 0x. Are you getting me? The same manner, this one also, we are going to get 2 root 2 minus 2 root 2. Okay, and this they are like terms. So definitely if I subtract 2 from 2, I'm going to get what 0 root 2. So we do not write 0 root 2. Are you getting me? We don't write that at all. So it cancels away and it goes away as a bus. So here I'm having 6 plus 3 roots of 2 all over. Then what do I have left there? I have positive 4 here. Then I still have this negative 1 in a bracket root of 4 bracket close. Are we good? Very good. So this is what we are having. This is what we are having here. I believe you are not confused. So you see problems involving binomial denominators. Look at what we are going through. Please have it in mind that you take your time when you are solving. You take your time. You solve it step by step. It is not difficult. Take your time and you will understand it. Good. So let's continue with life. Now, from here, I can claim here and continue from there. So claiming what I have up here, I now have 6 plus 3 roots of 2 all over all over 4 minus 1 in the bracket. You know root 4 is what 2. Root 4 here is 2. I believe you know that. Very good. You know root 4 is 2. You want me to prove why root 4 is 2? You said root 4 is the same as root 2 all squared, and this square will cancel that. Okay, that is why we are getting 2 here. Very good. So continuing with life, I now have 6 plus 3 roots of 2 all over. So this one I'll use to expand. So I'm going to get 4, and then the 1 is a whole number, so it will multiply that. Let me get rid of this so that I can get more space to continue with my process. Okay, so I have 4 minus 2 because the 1 will multiply the 2, giving me what? 2. Alright, so we continue. So I now have 6 plus 3 roots of 2 all over 4 minus 2 gives us what? 2. Okay, very good. So I can term this as our final answer. And I will advise you that please never cancel the 2 and then the 6 will no, because the numerator is a binomial. Okay, so you cannot use the denominator, this 2, to cancel that. Okay, you can only cancel when you split it up. So when you split it up like this, all over 2, that one you can decide to cancel the 2 here by the 6. That one it is accepted. Okay, but when you decide to cancel the 2 here by the 6 straightforward, that one I am sorry, it is mathematically inaccurate. It is mathematically it is not accepted in mathematics. Okay, very good. So we will end here as our final answer, and this is what we are having. I believe we are good with that, and I believe I can leave question 2 for you to try your hands on, and you can also do it. All right, so I'll leave question 2 for you. You try your hands on it, then you leave your answer in the comment section, then we check that. Okay, very good. So thank you very much for staying tuned, and I'll advise you that your colleagues are also out there who need such help. So please make sure you share this channel with them so that they will also enjoy the benefit that you are also having now. Very good. God bless you, and stay tuned always. Subscribe as well so that you'll be the first person to get in touch with our video anytime that we upload videos like this on board. There are more problems to look into, so stay tuned. Have a wonderful day. Bye bye.